Howdy there, Internet students. Mr. Hermanson again. Today we're going to start lesson 1.4b. We're actually going to learn how to use technology to make predictions based on data that we see. We're going to find that your calculator can actually make equations for you. But to help you understand the process here, let's take a look at this problem. This has the number of breaths per minute of people before and after exercising. One thing you should notice right away is that no matter how many breaths per minute they had before exercising, their number of breaths per minute after exercising was higher than that. And what we're going to look for is maybe a relationship like, is it possible for me to predict, like let's say that my resting breaths per minute is, say, maybe a little higher than some of these. Maybe I'm a heavy breather. Say it's 50. Could I come up with a formula that would predict what my heartbeats per minute would be after doing this same exercise? Okay. Um, so uh, so what the first thing we're going to do is graph all of these points, and I'm not going to make you do that. Um, I did that for you. Here it is, the exercise results. And one thing you should notice right away is that the exercise results is showing a linear pattern, that they kind of all line up in a straight line. And when that happens, we will be able to make a prediction. Okay. Now, what we're going to do is draw in a line, and we call this a line of best fit. Now, right now we're just using the eyeballing method. I'm just doing it by hand. Um, what I'm going to do is, first of all, take a line, and notice if I make this line really thick, I almost cover up all of those. So I'm going to choose a little bit thinner line here, and I'm going to draw this line in. First of all, I want to get the slope right. So I'm going to put the line underneath the dots and kind of mess with it a little bit until I think it has the right slope. Now you can do this with a ruler yourself, or some kind of a straight edge, uh, and then draw in your line. But I want that line to represent the data, the points on the graph. So now I'm going to slide it. Now I think I have the right slope. I'm going to slide it into the data so that I get it to the point where it looks like about half the points are above the data, about half the points are below the data. And I think that looks pretty good. Now, what I just did there by hand, you can actually use technology to do that, computers, computer software, stuff like that, which we're going to learn how to do. But I just want you to see what the process is. Basically, I just averaged. Um, and now I have a line that represents that data. So I'm going to make the equation for that line. The first thing I'm going to do is look for 2 points on the line that I can use to get my slope. That one looks pretty good right there. And maybe that one there. Actually, I'm going to change my mind a little bit here. Um, I think the one I got there and this one right here are both at the same slope as the line. Okay, now I'm going to figure out what those dots are. One is at 20 breaths and the other is at 30 breaths. So at 20 breaths, and it was the lower one of the two, that's that one, 2068 and 3091 are the 2 points I'm going to use. Now you could pick different points and your slope would probably be about the same as long as your line kind of averages out those points in the way mine did. Okay, so I need to find the slope between those 2 points. So I'm going to do 91 minus 68 over 30 minus 20. Okay, that's 10, and 91 minus 70 would be 21 plus 2 is 23 over 10. And if I divide that, I get 2.3. So my slope is 2.3. And what that means is there's going to be 2.3 heartbeats per breath. Okay, so so basically what we're saying is that your breaths are going to double. Okay, and if you look at the data again, you can kind of see that it's actually a little more than doubling, but that's part of the equation. Now the other thing I need is the y-intercept, which is right there, and that looks to be about 16 on the graph. Okay, so now I have an equation that I can use to model that data, and it's y equals 2.3x plus 16. I can remember that original question I had, what if my breaths per minute resting is 50? What would you predict for the heartbeats for that? And what we could do to figure that out is just my breaths per minute resting is the x variable, so I could just take 2.3 times 50 and then add 16, and that would be my prediction. It's not going to be exactly right, but it should be pretty close because this data is in such a nice straight line. Okay, so 2.3 times 50 equals 115 plus 16 is my y-intercept, is 131. So a person who starts out at 50 breaths, I would predict about 131 heartbeats. Okay? All right. It's really, sometimes data doesn't always work out so nice like this, and you can't model it in a linear way. And there's other ways to model it, but we're going to kind of focus on the linear ones. So there are different kinds of correlations, though, and let's talk about those. So we're going to just make a couple predictions here. You guys go ahead and use my equation and answer these two questions. Here's my equation. 2.3x plus 16. Okay, go for it. Now in the second one, you came up with 246 heartbeats. That might not be that reasonable. I know if my heart was beating that fast, I probably wouldn't live very long. So we should talk about limits of modeling. And I'm going to throw a couple words at you. You don't have to remember these yet, and this will be more of a high school thing. But our data range goes from 16 breaths per minute to 44 breaths per minute. And if I make predictions within that range, my model should be pretty accurate, fairly accurate. And that's called an interpolation when you do that, when you're within the data. You can write this down if you want. So within data predictions. And generally speaking, within data predictions with mathematical models are pretty accurate. Okay. When you go outside the data, like we did with the 100, the 50 and the 100 beats per minute, that's called an extrapolation. And extrapolations have some problems because you're not actually using the data. They tend to not be as accurate sometimes. Sometimes they are, sometimes they are, but you need to be a little bit careful with them. All right. Okay. So if the x values go up, and the y value goes up with them, that's called a positive correlation. Okay, and you can tell on a graph because your trend line goes this way. Okay, which was what happened. basically, as your breaths went up, your heartbeats went up. So both variables are going up. Okay, a negative correlation is when x goes up, y goes down. And that would look like this. So when you draw your line of best fit, you'll notice the points going this way. Okay, so basically, if you have an increasing line, or the dots are showing an increasing trend, then it's called a positive correlation. If you have a decreasing trend, it's called a negative correlation. All right. Sometimes there is no trend at all. Sometimes data just doesn't fit together and make any kind of a pattern. Then we say there's no correlation. So on a graph, you might see dots just scattered everywhere all over the graph. Okay. Now remember, these were like dots that this line is showing, so the dots would be around a line like that. And this one, the dots would be around a line like that. Okay. Now, an outlier is just some data that is extreme, so it doesn't follow the trend. And I'll just put a point in so you could see what I'm talking about. So let's say, like on this up here, if there were another point on there and the point was like way over here, that would be considered an outlier because it's so far away from the other data. All right, so in this example, we saw positive correlation because both variables went up. It was an increasing line. And is there always a correlation between two data sets? No way. In fact, most data sets don't have any correlation. Like if you correlated the size of your house against, see what would be a good thing for that, the size of your house correlated with your shoe size. So basically what I'm saying is just because you live in a big house doesn't mean you have big feet. Okay? All right. So let's check this out, you guys. And we're going to practice drawing a line of best fit by eyeballing as we do this. But I'm going to let you give it a guess. You're going to write positive, negative, or no correlation on each of these, and then you're going to see how you did. Okay? And also look for outliers if you think there's an outlier. All right? All right, graph one is really random. It's like a snowstorm. There is no correlation. If there is no correlation, then you can't talk about outliers. Graph 2, you should have said is a positive. Now, you guys, I'd like you to practice drawing a line of best fit. Now, here's how I do it. I first draw my line underneath it so that I can get what I think is the slope. And then I move it up into the line till I think I've split them up pretty much. Okay, so that line is trying to match the trend of those dots. Okay, now the closer the dots are to the line, the better the correlation. Okay, all right. For graph 3, you should have said there's a negative. And for graph 4, you should have said there's a positive with one little outlier. This one right here is an outlier. It just doesn't follow the rest of the trend. And go ahead and practice drawing a line of best fit for each of those. All right? Okay. Hey, you guys, for this one, I'm going to actually put this on the assignment, and I'm going to give you 3 examples. And you guys have to pick the one that's positive, the one that's negative, and the one that's no correlation. All right? So this lesson's done, and you can go ahead and start your homework, and we'll talk to you soon. Good luck.